Push that rock here with Simpson math. Let's graph a logarithm. Now, the way I like to graph logarithms is I first note the domain. It's always important to note the domain. Remember, the argument of a log, we can ignore everything else and look just at the argument, must be greater than 0. So if I solve this inequality, I subtract 3 and I have x must be greater than -3. So I'll set that aside for now. But we need to remember that. That's super important, the domain restriction. You can only put in x values that are larger than -3. But I'm not going to need to know that at first, because the way I'm going to graph logs is I'm going to find the inverse. Now remember the steps to finding an inverse. First, you just write that as a y. Then you swatch x and y. So I literally wrote x as y and y as x because we're going to change the x and y position when we get the inverse. Now I have to get rid of this -1. You're going to have a lot of problems with a -1 in front. It's like in chemistry when you do pH, there's a negative out front. To get rid of it, you multiply both sides by -1. So multiply this x by -1, then I multiply the log by this negative log by -1. Well, a negative times a negative is going to give me a positive log. So I end up with a positive logarithm, and that was the whole point of multiplying by -1, to get rid of that negative. That's tricky. So we get rid of that negative, and now we have the logarithm isolated. So we use the definition of log. This is the base. Logs are equal to exponents, so this must be an exponent. And the argument of log is the power to the exponential expression. Now I'm going to just subtract 3 from both sides, and I have the inverse function. So let's use this inverse function to help us graph the actual function we want to graph. So what I'm going to do is create a table of values for my inverse function. My inverse function, remember, is 2 to the -x minus 3. By the way, it might be easier for you to do it. This negative means the base is flipped, so it's a half, and then you can make the exponent positive. So if this is easier to deal with that. So I'm going to pick, and remember, exponents allow any real number in the domain. So I can pick any x value. So I'm going to make sure I pick some negative x values, like say, -2, and then maybe 0, and then +2, and maybe I pick -4 and +4, well, if this isn't enough. So putting in 0, 1/2 to the 0 is 1, and 1 minus 3 is a -2. So that was easy. Putting in -2, ooh, that's tricky. Here, I'll put it into this one. 2 to the negative of -2. Uh-oh, better watch out for that double negative. 2 to the negative of -2. That's going to give me a +2. So I have 4 minus 3, because that's a +2. 2 squared is 4, minus 3 equals 1. And then put in 2. 2 to the -2 minus 3. Well, like I said, this flips the base, so I have a half squared minus 3. So that's a 4th minus 3. So that's a -2 and 3/4. Okay, so is this enough points? Maybe not. I think it is. We'll see. But generate more points if you need more points. But let's remind ourselves, here's the inverse function right here, 2 to the -x minus 3. When we put in -2, we got out 1. When we put in 0, we got -2. And when we put in 2, what did we get? We got -2 and 3/4. Now, that's the inverse function, but we're trying to graph this logarithm function. Well, that was -log base 2 of x plus 3. But these are inverses, so we can just swatch. So this is 1, -2. See how I let the y value be an x and the x value be a y? I'm going to let this y value be an x, this x value be an y. Same thing here. And I have some points that are on this curve. And that was what I was after. Let's graph this curve right quick. I think we can do it right here on this sheet of paper. I don't think it's going to take that much. So I wish I wasn't so clumsy. But anyway, so I'm going to go by 1/4 of an inch here. I need to go out to, I didn't go out far enough. I need to go out to -3 on the x-axis, because remember the domain was greater than -3. And here's my y-axis. So here's my scale, here's my scale. So when x is 1, we have a -2. So when x is 1, we have y as a -2. When x is a -2, we have y as 0. when we have x is a negative 2 and 3/4. So negative 2 and close to the domain restriction. Remember, there was a domain restriction at negative 3. Remember, our domain had to be greater than negative 3. But at negative 2 and 3/4, it was at 2. Oh yeah, these logarithms have an asymptote. That's right, they have a vertical asymptote. Remember, the natural log function had a vertical asymptote. So there's the vertical asymptote. You say, well, last time it was going down. So, well, this has been flipped. Okay, so sometimes they're diminishing. This is a diminishing function, and it's going to diminish very slowly. What's this value here? Well, it's just whatever you get when you put in 0. Well, we'll get 0, comma, negative log base 2 of 0 plus 3 is 3. So 2 to the second power is 4, and 2 to the first power is 2. So this is some number between the 1 and 2, but it's been made negative. So see, notice we're between 1 and 2 on the negative side. So we could estimate it at, I don't know, what is that, negative 1.7. That's a really rough estimate, but it'll work. But there's our graph. That's the graph of y equals negative log base 2 of x plus 3. And it's a fairly nice graph. No calculator needed. Math made simple. Simpson Math.